All right, welcome back to our next day of class. Um, let's go over the derivation of our cosine of alpha minus beta, because the more times we practice it, the easier it'll be. So I've kind of pre-labeled and given you some angles here so that it makes it a little easier for you to set up unaided. Maybe I would say I would probably give you a diagram on a quiz or a test. So this is, if you can fill this in, you're in good shape. So I'm going to fill in an angle alpha and an angle beta and see if you can. So at this point, we've labeled everything, and these are the pieces we know. And keep in mind, what we're trying to prove is, oh, where'd my crayon go? Oh well, is cosine of alpha minus beta. And what we're going to do is we're going to set up, using this diagram, the law of cosines as well as the distance formula. And I notice I did this opposite from what I had done last time, but as long as we keep it in the same order, we put the betas first and then the alphas, we'll get the same answer after we multiply. So now go about simplifying both of these. And now that we have both of our formulas, well, now we can go in and set those two things equal to one another. All right, and then there's our identity of cosine of angle alpha minus angle beta. I just want to show again where our other identity with cosine of alpha plus beta comes from, and I gave a little hint of the identities that we used last time. What we did, and I'd like you to remember this, is we replaced beta, all the betas we have, with negative beta. And so there's our angle addition there of alpha plus beta, and this is our other identity. Today I also want to look at where sine of alpha plus beta comes from. And again, it takes a little intuition, and if we were in class, I might give us some time to try to come up with it. But one thing we might try to do first is, we know this identity, right? This is our one of our cofunction identities. And if we played around for long enough, we might come up with making another little substitution. Since we have these angle addition rules and angle subtraction rules with cosine, I might want to turn theta into two different pieces. I might want to turn it into two angles, alpha and beta, just so that hopefully we can come back and use some of these rules. So look at this substitution. And again, I don't expect for you to say, oh, we should substitute randomly theta equals alpha plus beta. But let's plug it in, and I think after we do it, you get a little more idea of why we wanted to use this. So I'm going to plug it in over here. Right, so again, I just kind of forced it in. I said, hey, I know this identity. Let's play around and see what happens, because we want an alpha plus beta in sine. So we have alpha plus beta. I'm not sure why this says negative here. Let me change that. An ugly plus, but oh well. And if we try playing with this, we can... Let's do it the wrong way first. So here's cosine of 90 minus alpha plus beta. If I plug this in to our formula up here, right? So again, I'm just using my rule for one angle minus another. So up here I have cosine, oops, very top. I have cosine of one angle minus another. So this is how I expand it. That's exactly what I did here. But we run into a problem because cosine of 90 degrees is 0. So this whole term is gone. Sine of 90 degrees is just 1. So all I'm left with is sine of alpha plus beta, which is what we started with. So that's not very useful. So let's erase this. And instead, we have a subtraction here. Why don't we distribute this and see what happens if we distribute it? Again, a lot of this unit is trial and error. We don't have any rules for subtracting three angles, but let's group, instead of A plus B together, let's group 90 and alpha together. So again, I can use my identity that we've already proven we can use cosine of an angle minus another angle. Right down here we have cosine of one angle minus another angle. So let's expand it one more time using this rule. And we're just about done, but this looks a little ugly, and this certainly doesn't look like the rule from our other page, which was over here. That doesn't look like this pretty alpha, beta. But hopefully, we're still thinking about our cofunctions. Look at what we have here. Cosine of 90 minus alpha, that's just sine of alpha. Sine of 90 minus alpha, that's just cosine of alpha. And so this is where our identity comes from after we use those cofunctions. Sine of alpha times cosine beta plus cosine alpha times sine of beta. If I want to get my sine of alpha minus beta, my fourth of these, well, do what we did in the beginning with cosine. Just change all of your betas into negative betas, and that's where our other identity falls out. So the last part for today, let's do some of the examples that we didn't do yesterday. So it says, suppose that this is my sine ratio and this is my other sine ratio, right? Two different angles, one sine ratio for alpha and another sine ratio for beta, and they give us these restrictions, which, as you know from our first two tests, are very important. Well, we want to find the cosine of alpha plus beta. That's our final goal. So set up the two pictures first. I'm going to draw them as two separate diagrams, or else it gets a little too messy. So draw these two diagrams first. So it's very similar to the questions we did in our first unit. Now that I've found they gave us the two sine ratios and I found the two cosine ratios, all I have to do to find cosine of alpha plus beta is plug it into our equation. So I'll put it all together now. All right, so hopefully you saw this question is really just applying our new identity to those processes from our first unit of setting up the two ratios. Please be very careful with what quadrant you're in. Negatives are super important. All right, see if you could set this one up by yourself. You could pause the video and I'll do it. Sorry for that silly error before. I forgot what I was doing. But this is correct, right? To get this side, just set up your Pythagorean theorem. And now write the two ratios out for the two cosines of alpha and the cosine of beta. And now if they asked us to find the sine of alpha minus beta, well, again, you're just going to plug it into that identity. And there's my answer. So we've kind of not done identities like we did in the beginning of the unit in a while. So let's apply some of these new rules. So I see an identity like this, and I'm thinking, okay, well, this looks strange. But I have one angle adding another angle. So let's write out our identity for cosine of alpha plus beta, right? I'm adding two angles. So expand this side. Right, so it might have looked strange at first, but this is angle addition. This is a sum of two angles. All right, and I look at this, and probably by now you understand what you're doing here. I see two angles, and I'm subtracting the difference of two angles. Well, expand this with the identity that we've proved first. And that's how we do that question. The only reason why I put up this question in class is, in a way, it's a real-life application. I just took this from a past ACT test. They gave you the equation, though, but if this is the first time you've seen this identity, you're probably going to, get a little worried and not just calm down and plug in what the information they give you. But they're literally asking, use our sign of alpha minus beta. And even if they didn't give you this, I bet you could have figured it out. But it's really just look up what each angle is and plug it in. All right, so homework, complete the classwork. I'm trying to think as a video. This will be posted under Tuesday's date. So please go on our website and click on Monday's date. This will be posted under Monday's date so you can see what the classwork is and also have the answers on there for you to check. This test Friday is wrong. Ignore that. That was from, I forget when. So please make sure you're working on your sum and difference proof, and make sure you can substitute things like negative beta in so you can get the other identities, and this we'll do next time. Also, I wrote these again because these are things you should be able to write out without too much effort.